Welcome to my YouTube channel Passionate Piping Engineer. In this video, we are going to learn about codes and standards as well as the recommended practices that are used in design and fabrication of piping systems. Introduction to codes. Codes. Codes is a systematic document giving guidelines required for design, fabrication or construction, installation, inspection and use of the material of pipe and piping system. This installation guidelines are prepared in such a manner that it can be adopted by the legal judiciary and can be made into law. As we know that codes defines the rules and regulation for safe design and construction. It addresses the following design requirements. First one is allowable stresses and stress limits. Allowable stresses or allowable strength is the maximum stress or tensile strength that can safely be applied to a piping system. For 31.3, that is for process piping, the allowable stress is tensile stress at temperature divided by safety factor, that is 3. The same for 31.1, that is for power piping, the allowable stress is tensile strength at temperature divided by a safety factor, that is 3.5. Second one, allowable dead loads and load limits. Dead loads are the loads which does not change, or we can say they are fixed loads. They can be in the form of tensile or compression. We can even say that they are self-load of the empty pipes, fittings, valves, flanges, etc., which do not change during the lifespan of the plant. Third one is allowable live loads and load limits. Live loads are the variable loads, or we can say moving loads, which can have significant dynamic elements and may involve considerations such as impact, momentum, dynamic of fluids, vibrations, hydrostatic pressure, etc. The fourth point is material. It is the most important factor in this list because the pipe materials are selected depending upon the type of the fluid for which they are used to transport. They can be corrosive, explosive, flammable, reactive, and hazardous to environment and also to the human beings as well as the wildlife. The fifth point here is minimum wall thickness. Normally, wall thickness or schedule is the difference between the OD and ID of the pipe. It is the wall thickness or schedule for pipes and fittings which are without corrosion allowance for each component of a piping system based on appropriate design code calculations. The sixth point here is maximum deflection. While determining maximum deflection, we should not exceed 5% of the pipe inside diameter. For pipes, the stiffness and long-term mechanical properties are to be used for a theoretical prediction of deflection. The seventh point here is seismic loads. Seismic loads, also called as the earthquake loads, are the loads which may be analyzed using either dynamic or static methods. The eighth point here is thermal expansion. As we know, metals expand when heated and contrast when the heat is removed. That even means it is directly proportional to temperature change. Similarly, all the pipes and vessels expand due to temperature of fluid flowing through it or from the environment. Similarly, all the pipes and vessel expand due to temperature of fluid flowing through it or from the surrounding environmental ambient temperature. There is one note to be remembered. Piping codes does not include components such as fittings, valves, flanges. They rather define the design requirements for these components with reference to the industry standards. Introduction to standards. Standards. Standards actually provide specific design criteria and rule for individual components with their classes or ratings, such as flanges, valves, and fittings. They are prepared by the professional group of committee which are believed to be good with proper engineering practice and which contains mandatory requirements and dimensions. The users are responsible for the correct application of all the standards used while designing a piping system. So let us see the types of standards used in piping. So standards are classified into two types. First is dimensional standard and second is pressure integrity standard. Let us first see what are dimensional standards. Dimensional standards. Dimensional standards provide configuration of control parameters for all piping components. The main purpose of dimensional standard is to ensure similar components manufactured by different suppliers will be physically interchangeable. Mainly, this document gives dimensions of various parts or various components. Pressure integrity standard. This standard provides minimum performance criteria of the piping system. The main objective is to ensure that the components are designed and manufactured to the same standard will function in an equivalent manner. Recommended practices. Recommended practices are prepared by the professional groups or committee indicating good engineering practices but which are optional. Companies also develop guides in order to have consistency in the documentation. This standards covers various engineering methods which are considered good practices without specific recommendation or requirements. Each country has its own codes and standards. Major organization for standards are: first is India, that is BIS, Bureau of Indian Standards. USA, we have ASME, American Society of Mechanical Engineers. Normally, American national standards are most widely used all over the world. UK, we have BSI, it is British Standard Institute. Germany, it is DIN, Newton's Institute for Normung. Japan, we have JIS, it is Japanese Industrial Standard. Europe, we have CEN, Europe Community for Standardization. Canada, we have CSA, this Canadian Standards Association. In France, we have AFNOR, Association Francoise. One more standard we have for worldwide is ISO, International Standard Organization. Some of the commonly used American standards in pipings are API, American Petroleum Institute. Rules and standards for oil and gas industry is issued by this institute and is followed by almost all the oil and gas companies in the world. AISI, American Iron and Steel Institute. AISI standard specifies the material by its chemical and physical property. When specific model of manufacture of the element is not to be specified, then material can be identified by AISI standard. ANSI, American National Standard Institute. ANSI standards are used in the design of piping system. This committee was recognized as ASME code for pressure piping B31 committee, and eventually the code was changed to ASME B31 for pressure piping and are adopted as the legal requirement. ASTM, American Society of Testing Materials. ASTM is a society which has developed a collection of documents called Material Specification for standardizing material of large use in the piping industry. AWS, American Welding Society. This standards provides welding related information such as fundamentals of welding, welding design, testing and inspection of weld, and gives a guidance on applications and use of welding. In addition to this, welders training qualifications are also included in the standard. AWWA, American Water Work Association. The American Water Work Association standard refers to the piping elements that are required for low pressure water services. These are less stringent than other standards. Large diameter water pipelines which requires large valves, flanges, etc. are covered under these standards. Actually, these standards are very rarely used in piping engineering. ASME, American Society of Mechanical Engineers. ASME standards provide us the design, dimensional and fabrication criteria for many commonly used piping components for use in refineries and chemical plants. ASME B31.3 process piping systems, and ASME B31.1 is for power piping system. MSSP, Manufacturer Standardization Society and Industrial Standard Practice. In addition to all the above standards and material codes, there are some standard practices followed by the manufacturers. These are actually published as the advisory standard and are widely followed in the piping industry. Let us see some of the ASME B31 pressure piping codes. ASME B31.1, that is power piping. ASME B31.1 code is used for design and fabrication of power piping found typically in electrical power generation stations, industrial plants, central and district heat and cooling system. This code actually covers the high pressure and temperature piping of power boilers, which includes external piping where steam is generated at high pressure of more than 160 psig and at a high temperature of about 250 degree Fahrenheit. Second one is ASME B31.2, which is fuel gas piping. ASME B31.2 code covers the design, fabrication, installation, and also testing of piping systems for fuel gases such as natural gas, liquefied petroleum gas, that is LPG, in gaseous phase. ASME B31.3, which is very widely used, that is process piping. ASME B31.3. ASME B31.3 code is used for design and fabrication of process piping for all fluid services, pressure at 0 or below 15 psig, as well as for metal and non-metallic piping found typically in petroleum refineries, chemicals, petrochemicals, textile, paper, semiconductor, and cryogenic plants. ASME B31.4, pipeline transportation systems for hydrocarbons and other liquids. This code is used for the pipelines that transport liquids between plants, terminals, pumping, regulating, and metric stations. The liquid used for transportation through these pipelines includes crude oils, natural gasoline, liquefied natural gas, that is LNG, liquefied petroleum gas, that is LPG, petroleum and other liquid petroleum products between tank farms, refineries, terminals, can be through rail, marine, and truck. The next one we have is ASME B31.5, refrigeration piping. This code is used for design and fabrication of pressure piping containing refrigerant or secondary coolants, which includes heat transfer components such as condensers and evaporators of pressure up to 15 psig and temperature of about minus 320 degree Fahrenheit or minus 196 degree Fahrenheit. The next one we have is ASME B31.8, that is for gas transportation and distribution piping systems. This code is typically used for gas transportation piping between sources and terminals, just as in the case of offshore and onshore pipelines facilities used for transporting of gases. Piping at compressor, regulating metering stations, gas distribution system, and gathering pipelines in respect to all pressure and temperature above 450 degree Fahrenheit, that is approximate 232 degree Celsius, or below 20 degree Fahrenheit, that is minus 30 degrees Celsius approximate. The next one here is ASME B31.9, building services piping. This code is typically used in the design and fabrication of piping that can be found in industrial, institutional, commercial, and public buildings and in the multi-unit residences. It actually does not require the range of sizes, pressures, and temperatures covered in ASME B31.1. ASME B31.11, slurry transportation piping system. This code is used for design and fabrication of the piping system that transport viscous slurries between plants and terminals, within terminals, pumpings and regulating stations. Now let us see some of the API, ANSI or ASME, ASTM standards followed by the MSSP standards. So let us start with API standards. API 5L is a specification for line pipe. API 60 is for pipelines, valves, enclosures, connectors, and swells. API 6F, the recommended practices for fire test or valves. API 593 is for ductile iron plug valves. API 593 is for ductile iron plug valve flanged ends. API 598 is for valve inspection and test. API 600 is for steel gate valves. API 601 is for metallic gaskets for refinery piping. API 602 for compact design carbon steel gate. API 604 for ductile iron gate valves flanged end. API 605 large diameter carbon steel flanges. API 607 fire test for soft seated ball valves. API 609 is for butterfly valves. API 1104 standard for welding pipeline and facilities. API RP 520 is for design ABT installation of pressure leveling. Part 1 and Part 2A is for system in refineries. API RP 521 is guide for pressure relief and depressuring system. API RP 550 is for large diameter carbon steel flanges. API 1102 is for railroad and highway crossing. API 5B is for threads on pipe. API 594 for check valves. API 1110 is for testing. Now let us see some ANSI or ASME standards. ANSI B 1.1, that is Unified Inch Screw Threads. ASME B 1.20.1, pipe threads for general purposes, that is extension is in ANSI B 2.1. ASME B 16.1 is cast iron flange fittings. ASME B 16.3 is malleable iron threaded fittings. ASME B 16.4 is cast iron threaded fittings. ASME B 16.5, that is stainless steel flanges and flange fittings. ASME B 16.9, that is steel butt welded fittings. ASME B 16.10, face to face or end to end dimensions of valves. ASME B 16.11, that is for forged steel, socket welded and threaded fittings. ASME B 16.20, that is for metallic gaskets for pipe flanges, ring joints, spiral wounded and jacketed flanges. ASME B 16.21, that is non-metallic gaskets for pipe flanges. ASME B 16.25 is for butt welding ends. ASME B 16.28, that is short radius elbows and returns. ASME B 16.34, that is steel valve, flanged and butt fittings. ASME B 16.42 is for ductile iron pipe flanges and flange fittings class 150 to 300. ASME B 16.47, that is large diameter flanges, which is 26-inch NPS to 60-inch NPS. ASME B 18.2.1, that is square and hexagonal head bolts and nuts and 2 inches and ASME B 36.10, that is welded and seamless wrought steel pipes, and that is also called as carbon steel pipes. ASME B 36.19, welded and seamless authentic stainless steel pipes. ASTM standards. ASTM standards consist of 16 sections of definition and clarification of material and construction and testing methods. Most of the ASTM standards are adopted by ASME and are specified as a ASME section 2. The ASME section 2 has 4 parts. First one is part A, various material specification which are of steel. Part B is non-ferrous metal specification, which has alloy steels, nickel, copper nickel. Part C has specification for welding materials, which has the weldable property. Part D has the property of materials. Some of the ASTM standards are ASTM A53, steel pipes and zinc coated welded and seamless pipes. Zinc coated also mean as the galvanized pipes. ASTM A105, forged carbon steel piping components. ASTM A106, seamless carbon steel pipes for high temperature surfaces. ASTM A181, forged carbon steel fittings for general purpose piping. ASTM A182, forged alloy steel pipe fittings, flanges, valves for high temperature surfaces. ASTM A234, pipe fittings of wrought carbon steel and alloy steel for medium and high temperature. ASTM A312, seamless and welded authentic steel pipes. ASTM A333, seamless and welded steel pipes for low temperature surfaces. Some of the MSSSP standards: MSSSP 6, standard finishes for contact surfaces for flanges. MSSSP 43, wrought stainless steel but welded fittings. MSSSP 56 is pipe hanger supports, material design and manufacture. MSSSP 67 is for butterfly valves. MSSSP 72 is for ball valves. MSSSP 83 for pipe unions. MSSSP 88 for diaphragm valves. MSSSP 97 is a standard for OLED fittings. I hope you have understood the topic of this video, as I have tried to cover and break down all the important codes and standards that are used in our day-to-day working for all the piping professionals, which includes draftsmen, designers and engineers. All the red highlighted codes and standards in this video are very important as they can be asked in a job interview. Thanks for watching this video, and if you like the content of my video, please don't forget to hit the like button and share it with your friends, because sharing also increases our own knowledge. And yes, don't forget to subscribe to our channel Passionate Piping Engineer, and also press the bell icon below to get the latest notification of our upcoming videos. Till then, stay tuned and take care.